Hello everybody. In this video, I'm going to take you through all the nuts and bolts, ins and outs, pretty much everything of data frames in Python. So what is a data frame? It's basically a way to structure data in a format that shows rows and columns. That's ideal for any kind of tabular data. You can think of an Excel spreadsheet, maybe a table in a database. The functionality is quite a bit different from those, but the presentation and the view on the computer screen is actually pretty similar to a spreadsheet or a data table in a database. So what can you do with data frames? Any kind of manipulation, cleaning, filtering, transforming, aggregating, pivoting. You can do exploratory data analysis, data storage and retrieval, any kind of handling of time series data, any kind of merging, joining, data processing for machine learning. I've got several videos on machine learning. You should check those out. Any kind of relational data representation, data cleaning. We're going to see so many examples today. I'm going to try to make it generic so it's applicable to your use case, but also I'm going to go into a lot of details too to show you the full potential and capabilities of data frames, but this is not going to be completely exhaustive and absolutely comprehensive because there's so many different use cases. I mean, the video will go on for hours and hours and hours, and you would basically get bored and leave. I don't want that to happen. But there are many, many, many things you can do with data frames in Python. I'm going to try to show some of the more popular and functional and practical examples here. So here's 3 data frames that I'm creating. I'm going to concatenate these 3. You have df1, df2, df3 with columns A, B, C, D, E. This one just has, the third one just has A, B, C, D, not E, but it's fine. Go ahead and do the concatenation right here. Okay, and you can see the result, everything is concatenated together. And since we didn't have an E on the third data frame, we actually get nans. And that's totally fine. That's exactly what we'd expect. Anything that matches goes into the column of the feature or the column name that matches. If it doesn't match, you get a nan because the value simply doesn't exist. A nan stands for not a number. There's just no number. There's no data point to fill in here. So a nan is totally fine. You will see those sometimes. You can zero those out. You can backfill nans, you can forward fill nans, you can use some machine learning techniques to fill in missing values. I'll have another video on that coming out pretty soon. But a nan just doesn't exist. It's not a number, it's not a 0, it's not blank, it's just basically nothing, right? So let's do a concatenation. Let's do a merge. Instead of by column, we're doing a merge now. So everything is merged horizontally across the top of the field. And some of these headers are repeated, right? So the PD concat over here is basically stacking everything underneath each other, right? And if we look at frames and the merge is done by row instead of by column, now we're doing kind of a different, getting kind of a different result here. This use case isn't as common as the one that we see above, but it's still used pretty frequently, right? So instead of concatenating by column and looking for similar column names, we're concatenating by rows over here. Okay, so there's just another use case. Now we have a whole bunch of nans because there's a lot of values that don't match up. Now we're looking at an example of a merge, merging data frame 1 and data frame 2. As an outer merge, right? And we saw that 1 and 2 have A, B, C, D, and E. They have all of the columns together, and then we get the indicator over here as a separate parameter. These data frame merge libraries have a lot of parameters you can add in. You have to Google it, and you have to look at the documentation. There's way too much for me to get into here. I'm just trying to give you a general overview of how these things work. But to get into the details, you have to look at the documentation. It's very rich. It's very comprehensive. They go into all kinds of use cases, things you can't even probably imagine. So this is just a general overview of how these things work, just to whet your appetite, but to learn all the nuances really takes a lot of time and a lot of patience. You have to invest some effort, but it really pays off. There's so many pretty cool things you can do with DataFrames. I'm going to take you through the high-level stuff right here. So here's another example. You can merge based on keys. So the key would be the index of the data frame. So you can merge based on index, based on column names, based on rows. There's many ways to do these types of merges. You really have to understand what the eventual outcome needs to be, or what's the ask when you talk to your client or the stakeholder, understand what they're looking for, and then plan accordingly, right, and execute to meet the demand. But these data frames are extremely flexible, and there's almost nothing. I've never seen any exception of what you can't do with the merging, concatenating, transforming, pivoting, filtering. I've never seen too many examples of what you can't do. I don't think I've ever seen any limitations. So you just have to understand what the end game is, and then you can figure out how you're going to achieve that goal. So here's another example of merge, DataFrame 1 and DataFrame 2. Here's a cross merge. So this is more like a Cartesian product. So you're getting every possible combination. There's not too many use cases for this in the business world. But one that makes sense to me, I've never really done this before, but it would make sense, is if you had several sports teams. Let's say hypothetically you have 10 sports teams, and you want all 10 sports teams to play each other. A Cartesian product, or a cross product, in this case, here's a parameter called cross. A cross product or Cartesian product, it's the same thing, would help you to figure out the schedule of how to make all 10 sports teams play all 10 sports teams. But in the real world, this isn't used too much. But this gets every possible combination of everything, right? And I'm putting this a link to the documentation of how this works right here. I'm going to save this file as an HTML file, and or save this Jupyter Notebook as an HTML file and post this when I post the video. So you can open the file, just double click it, download it, and open it, and you will have exactly the same view that I see here. You'll have this on your own workstation or laptop or whatever you're using, and you can copy and paste the source code. You don't even have to paste it; like it will just run in the workbook because it opens as a HTML file, and you can run this in real time and see how all this works and interact with it and pick it apart, disassemble it, reassemble it, and see how everything works. It's very interesting. It's pretty fun too. So here is an example of taking a subsample from a data frame. Sometimes these data frames are so massive they can create hundreds of millions, or they can contain hundreds of millions of rows or billions of rows, and it's just too big for maybe some machine learning models to run over, to learn the nuances of the data and get trained and tested and make predictions. Maybe it's too big. Maybe the data frame is so big your processor can't handle it, your cloud environment can't digest the data or whatever. You can take a random sample, and if the data is normally distributed, you should be able to take a fractional sample, maybe 25%, 50%, and work with a subset, and you're going to get essentially the same results as if you worked with the entire data set, right? Like, it's better to work with the whole data set, but if the processor just can't handle it, that's fine. Just take a random sample and work with that and get the results and display that to your client, or work with your stakeholder and show them the outcome or the takeaway from that. So it's better than doing nothing, right? If the data set is just massively incomprehensible to work with, it's just simply not going to work. Just take a subset and make it working. Make it work, get it going, get the results, and move on, right? Here's an example of pivoting a data frame. So let me run that. Control Enter to run. Here's the original data frame at the top and the pivoted data frame underneath. So we're pivoting by column is player, values is points, and the index is the team, right? And you can see on the left-hand side, the index is the team. That's kind of the row. The player is the columns at the top. And then you see all the values underneath. And I'll tell you, this is a multi-index data frame. These are a little bit more tricky to work with. Sometimes you have to flatten that. Sometimes you have to melt that to get it to do other things. But if your only intention is to pivot it, then this will do that. But I'll just warn you right now, sometimes you get multi indexed data frames, and those behave a little bit differently than a single index data frame. Okay, all the documentation is displayed right here. I'm sharing that with you. I'll share this file with you when I post the video. So here's an explanation. Here's an example of getting data from seaborne data sets. This all comes from the web. This is flight data. We're taking it and doing an aggregation of passengers. We're looking at counts, sum, means, which is an average, and the min and the max. Okay, so again, simple aggregation, Control Enter, and you have everything from your flight data right there. So this is pretty cool, right? In 1 second, we have the year, the count of count of passengers. I guess it's always 12 for some reason. I'm not sure what's going on there, but this data comes from their data set. So I'm not going to question that. It is what it is, right? You have the sum, the average, and the min-max of passengers flying on flights as a time series, 1949 to 1960. Okay, so stacked data frames will be sort of one stacked underneath another, and so on and so forth. So it gets very tall and very vertical. So let me run this, Control Enter to run. We have 72 rows and 3 columns. The columns are month, passenger, and year. So I see what this is doing. So it's basically just taking the data that we saw before, looking at the passengers, counts, mins, max, means. So just another view of the data if you're going to plot this or display this for some kind of client presentation. This could be useful. I wouldn't say this is the most common way to do it, but again, with these data frames, there's so many features available to you. Really, the sky's the limit. The only limitation is your imagination. You can do any kind of slicing, pivoting, aggregation, parsing, merging, joining, concatenating, whatever you want. You have to understand what the end game is and then pick the right solution for that. Okay, so here we're looking at stacked again, looking at the head and tail. So basically this takes everything and just stacks it in the minimal number of columns. So this is actually called an unpivot, or this is unpivot. Pivot is taking everything and spreading out over many columns, and unpivot is taking many columns and basically putting that into a very vertical format that has the minimum number of columns required, but to be very long. So one pivot is very wide, and unpivot is very long. That's two ways to think about it. Okay, here's resources, all kinds of documentation to the source material that I used for my research here. So what are we looking at here? Now we have animals as a data frame. This is just made up data. It's not coming from the web. This is just an example I came up with. Control Enter to refresh it. So we have animals, the diet of the animal, and the country. Okay, I see what this is. So the actual data in diet is stored as a list. So anything with square brackets is a list. It's comma delimited list. So let's say you want to get this into a format. This is pretty easy to read, but if you had to plot or chart this data, that's going to be very difficult to do in this format. We have to basically expand it and get it into a format that's more digestible or consumable for some kind of charting tool, either Plotly, Matplotlib, if you're using Jupyter Notebooks, or if you're in Python, or maybe Power BI, Tableau, if you're using that. So this explode right here, this property right here, we'll go ahead and explode that into a longer list. So again, we're looking at a vertical list of what we saw before. So we have the animal, the diet, and then the country that it's from, right? So we have herbivore, carnivore for Australia, for koala, kangaroo, and whatever that thing is. I'm not even sure what that third animal is, but you can see how it takes it and it breaks out all these lists into individual rows and columns, right? So you have more tabular and columns and row kind of setup. So this example right here is pretty interesting. Now we can do some more intuitive color shading, or what is it called? I guess just shading, I think. So if something is, let's see, maximum, we're looking at groups and means, and any kind of highlight max, that's the property over here, gets a light green. So any kind of maximum feature we'll get the light green. If we look at this, and the mass column, we have a bunch of nans. 5.125 is the light green. That's the max in that column. So distance 4144 is the max. And you can have the min, you can have the mean. But this is a way of using data frames to add some color or some shading to tease out what's the max, the min, the average. You could have any kind of different properties here representing colors to show you the importance of those different features. And then of course you can add multiple. You can have the max, the min, and any kind of nulls can be called out too. So anything that's a nan, like I said, not a number, is shaded in yellow. Anything that is a minimum gets coral color. You'd have to look at the documentation to understand all of this. I researched this before. And then light green obviously is light green. So those are the maxes, right? So that's how we get that. So that's another use case. Here's the empty cars. This is classic. I've used this data set in many of my videos. Now this is a dynamic data frame where you can move these features around or move these column names around interactively on the web page here and get different results. If I look at weight, this is weights of vehicles. I can actually move this down here and I have the weight of the vehicle. Let's say I want to get rid of miles per gallon. I can move that on the side and now I have the weights, right? The sum of the weights for all these vehicles based on horsepower. And if I want to replace horsepower by something else, I could take that out. I can put in maybe miles per gallon over here. So I have miles per gallon on the y-axis, weight on the x-axis, and we get the results over here. So this is pretty cool because you have a lot of different views over here. You have area chart, scattered charts, tree map, lots of cool things. So very interactive, very visual, very low code to get this working. And this is it. I mean, look at this, like 2 libraries and 3 lines of code. And that's all we need to be able to interact. So you don't have to write hundreds of lines of code to get this working. Just 3 lines of code and literally you are in business right here. Let me see what this looks like. I haven't even explored some of these things before. Or just a basic table and you get the results here. So pretty powerful stuff. There's a lot of things you can do with this, right? Let me hit Control Enter. This is a dynamic scatter plot of the data. So we have to pull down a couple things here. What variables do we want to look at? MPG. Like this MPG and horsepower. Those go together pretty well. Okay, put that down here. And again, heat map or whatever you want, right? Like you would pick, and that's the count. Okay, yeah, these are always going to be 1, right? So we have to take something else. So let's do a sum. No zeros. Okay, let me try something else here. I'm just doing this in real time. I have not looked at this prior. Median count. Maybe heat map isn't a good example. Maybe bar chart. Yeah, you'd have to try this and see what works for you. I'm trying to just see how this thing works in real time here. Okay, and not all these things are going to work all the time. You have to pick the best one for your use case and go with it, right? So here's another example. Now this is another interactive data frame here. Now this one, you can add select the number of total views or total entries you want to see, and then start typing here. Let me put in an A. Let me put in like let's see, Mazda, MA, Mazda. Okay, so we can see, oh, Camaro and Mazda are dynamically filtered out here because we put MA. Let me look for 1 or 2 others here. Maybe ER. What do we have? Duster, Merc, and a bunch of Mercs, right? So you can see how that happens, how that works, right? Oh, and Challenger, right? So you can dynamically filter your data frame. That is pretty cool. Getting kind of to the end, I know this one is dragging on a little bit, but there's so many cool and interesting things to talk about. So let's say you have 2 data frames that have times that are pretty close to matching up, but they don't exactly match up. If you're looking for a perfect match, that is fine. You can certainly do that. If you're looking for the closest match, you can do that. There's a different way to do that. So let me create some data frame here. Okay, this is stock trading data with a bid and an ask price, and then different time features, right? Like the date and the time throughout the day. Let me hit Control Enter to get this data. Okay, and let's say we want to look by PD merge as of time. So the PD merge function will do an exact match based on time. But if you want to look for the closest time, maybe you're looking at different markets around the world. Two data sets don't match up. Maybe you have data from Bloomberg. I'm just thinking here, what else would it be? And Capital IQ, and the data doesn't match up precisely by time. That's okay. You can still merge by the closest time using this feature right here, and you get your results. You can see how that works. This data frame, and this data frame scenario, you can actually merge based on longitude and latitude coordinates. So this merge is quite a bit different from the others. It's not a straight merge. It's not merging by time. Let me create the data frame, Control Enter. Okay, and you use this package or this library GeoDataFrame with GDP, which is GeoDataFrame. Let me see, GeoPandas. Okay, so there's two things going on here. The GeoPandas library and then the GeoDataFrame property right here will merge these two data frames. It actually converts it to a geometry data type. The data type has to be a proper data type, right? Let me hit Control Enter to refresh this. So there's a few data types in a data frame. You have an object, which can be a string. Typically, you have float, which is decimal data. You have an integer, which is non-decimal data. There's a few other things, and then geometry is a specific type of data, right, in this data frame. So you need this as a geometric data type property. Once you do that, you can go ahead and do the merge. There's some documentation here. Let me Control Enter, refresh it, and you can see how the merge is done here based on the closest geometric latitude, longitude coordinates. Okay, and I think there's just one more example. Let me scroll down here. I haven't looked at this in a while. Maybe one or two. Oh yeah, I know what this is. Okay, so we are merging several different data frames together, but there's a caveat here. Okay, so the data frame column names aren't going to match exactly in every scenario. There might be several column names in one data frame that match and several in another data frame that match, but there might be one new column that was introduced or one that was taken out for whatever reason, for various reasons. Sometimes they drop off, sometimes new ones are added. This will merge the data frames based on the similarity of the column names. So a long time ago, I had to work with a data set that had over 1 million different files, and I had to combine that into about 250 different data frames and load that into 250 different tables into a database. So the column names didn't always match up exactly. You had to run a script and look at how similar the data frame names were, and then merge those that were the most similar, and then if they were dissimilar, then those would go into a different data frame and go eventually into a different table. So I'm going to share all this code with you. I think my battery is actually running out here, so I'm going to finish this up. But you can cluster these based on similarity, refresh again, and then you'll get the final result at the end. So you can merge over 1 million files into 250 files that are substantially similar. In this case, we have 3. We went from 9 into 3 based on similarity of the column names. So that can be super useful if you're trying to do this with SQL or some other type of program. That is going to be not mind-numbing. It's going to take, I don't even know how long, weeks and weeks, maybe several months to figure that out. But this methodology will do that for you quickly and easily using a clustering technique. So I think I'm going to wrap it up here. My battery's almost dead. Hopefully you guys learned something new. Thanks for your time today. Have a great day.